Hello everyone, my name is Shreyash Zanjal and today we'll be talking about my project of data management, which is emulating Firebase. So one of the key features of Firebase is that it stores data in real time. So user can access and store data in real time. So in my system, I have used Flask and MongoDB to store the data, but the user has the functionality to access data in real time using Firebase curl commands. So let's move forward. So today we'll be talking about datasets first, and then we'll talk about indexing, and then RESTful APIs, and then I'll show what are the supported functions in this system, and then we'll move to command line interface to show how those commands work. And then finally, I'll show you how it is getting reflected in MongoDB Compass. So the dataset that I have choose was pizza restaurant sales. So the dataset is publicly available on the Maven's analytics website platform. I have chosen this, which was posted on a competition. And the dataset contains few relevant features, which I would talk, including order ID, order details ID, the pizza ID, quantity of pizza, order time, unit price of pizza, and the total price, the order date, pizza size, its type, the ingredients including in pizza, and the name of the pizza. So these are the 12 relevant features that I will be using. And when we look into the bigger picture of this project, so the insights will actually help us in understanding what days and times do we tend to be the busiest days, and like how many pizzas are we making during those periods, and what are the best and worst selling pizza, which is really important for any restaurants. And what is the average order value that you get during a day, a week, or a month, and how well we could be utilizing the sitting capacity of each restaurants. So the main part was indexing in MongoDB because it is the way to optimize and speed up queries in the large collection of data. So indexes are created on specific fields in a collection. And in my case, I have built indexes on order ID, order details ID, pizza name, so user can access it quickly. So which allows user to find and retrieve data based on those fields. So this is the script that I wrote for MongoDB in Python. I've used PyMongo and I have connected on my local host. I have kept a database as PizzaDB and collection name as Pizza Collection. Then I have created index on order details ID, order ID, pizza ID, its quantity, the order date, order time, unit price, and total price. And you can see on the right-hand side picture that it gets created on the MongoDB, and the ID underscore is created by MongoDB itself, and it is unique. Next, I'll show how I created the Flask RESTful API. So this is a web application which provides an API to interact with MongoDB database, which helps us to store information about the restaurants for which we had. So the API provides basically the endpoints to create, read, update, and delete the information about the data that we will be putting. So as I said, we will be moving into what are the supported functions that this system follows. So the first and very basic one is put command. So as you can see in my left-hand side of the screen, I have used a function put orders, where I would be getting data from the JSON file, and then I'll if the order is not present, then I would say ID is required, because the order ID is my basic ID, which I'll be taking into consideration when I'll be putting any order into the MongoDB. And then once it is done, we will be using collection.replace one, because we know put command works as it replaces everything in the Firebase. So as we are emulating Firebase, we want to emulate the implementation of put function in this system. And on the right-hand side, you can see when I do curl -x.put, and when I pass the details like -d using order ID, pizza ID, unit price, total price, it gets added. As you can see here, it returns the document that is being added in the MongoDB. But we have implemented this using Firebase curl commands. Next would be the post command. It's similar to the put command, but the only difference is the order ID that will be created will be a unique ID. As you can see, I've used UUID, And the order ID that you can see on the right hand side, it's a string, it's really unique, and it would be created regardless of what you put. Next is patch. So patch command is used to basically update whatever you have stored in the database. So in my case, I'm using collection.update1, and wherever you are providing the ID, it would update the data according to what you have put. As you can see on the right hand side example, I have used curl-x patch, and then I have passed the order ID, and then whatever changes I made here, it would return the acknowledgement that yes, the order ID is updated successfully. Other acknowledgements could be like the order ID is not found, or like no changes have been made. Next, we'll be getting in the get function. So in my system, I've used two routing ways for the get function. The basic routing would be if you provide a specific ID, as you can see here on the right-hand side. I have given him the ID that I need this specific URL using curl-x get command. And when I pass the ID, it will return me the document which contains order ID 100. And another route function that I have used is pizza collection JSON.get, where you can see here both of the routing functions, and the another function would basically work on the filtering function. So the filtering functions that I've shown here, the first one that it supports is limit to first. As you can see, the filtering functions, when we pass, we order it by some attribute. I'm ordering it by order ID. I'm then limiting it to first. As I've written limit to first one, it would show me the first document that is been stored in the database. Next is get limit to last. And in this case, it would give me the last ID. As I've ordered by ID, it would give me the last ID that has been found. And in my data set, as you can see, it's 21,350 would be the last ID. Next, there's a get at end filtering function. In get at end filtering function, when you order by order ID, you would get just one entry, and it would be ordered ascending by default with order ID. So if you are limiting your results to one, you would get just the first document that is stored in your MongoDB. Next, it start at. Now, in this case, I have ordered by unit price, and the unit price should start at 35. And the documents that it is returning, you can see, is 35.95 in the unit price. It is seen on the screen. And similarly, whatever unit prices which are greater than 35 would also be seen in the result that would be created. And the next is equal to. So while we provide equal to, you have to give again order by order ID. And when I say order ID equal to 100, it would give me a document which has order ID to 100. So those are the get filtering functions. And the last functionality that I would be showing you is the delete function. When you do curl-x.delete, and when you pass the ID that you want to delete, it would acknowledge and tell you that the order ID is deleted successfully. And if the ID is not present there, it would acknowledge and say that result order ID is not found. So this was the delete command that was executed. And that's my presentation. And I would be moving on to the implementation of how I did this in Python scripting. So first of all, the pizza dataset that I had collected was in CSV file. Then I had to convert it into JSON file, which is the format required in MongoDB. So I used this small basic script to convert my CSV file to JSON file. Then I have to upload my JSON file to MongoDB, which I have connected using my local host. And then I've made database collection, and then I upload it to MongoDB. Then this is my app Flask application, where I've routed every queries to each and every filtering functions, get functions, put functions, and delete functions. So to show you example, this is my command line interface. And let's see if I want to put something, let's say of order, let's say order 10. So I will just put order 10 and I'll hit enter. It gave me acknowledgement. And in my MongoDB, if I check, what is the order. So it gave me order IDs which are 10, and the first option that you see here is the one that we have put in our data set. Now let's say if I want to put order ID 100, I press enter, and then I get the acknowledgement that this is the order ID that has been put. And when I search it, I get the same but with different order ID. Now let's try another functionalities. Like if I want to post something, as I said, put and post has just a single difference, that post would create a unique ID that is been uploaded to the MongoDB. So when I press enter here, I'll get a very unique ID that is seen here. Let's copy this and check if it is present in MongoDB. So it's a string. I copy pasted it, and yes, the same thing, but with unique ID has been stored in the MongoDB. Now let's do delete. So if I want to delete something, I would just simply pass, let's say the order ID 100 that I've created, I want to delete it. It said order ID deleted successfully. Now let's check whether it is still present in our MongoDB. Yep, so no result, it has been deleted. Now let's get into some filtering functions. Let's say I just want to get 100. As I said, I've just deleted 100. So if I try to get 100, it would say error, order is not found. So let's try to put 100 back and now try to delete. Yep, now it says order ID deleted successfully. Now let's try patch. So before patch, let's put something again. I'll be putting 100 again, and let's patch it to, let's patch the total price of the pizza to, let's say 100. Now, if I press enter, it says order ID updated successfully. Now, if I check here, it says order ID 100, which is already present. Now, if I want to get function, you'll get the thing that we just found there. Now let's do get, but ordered by ID and equal to 100. Now again, we have ordered by ID, which is equal to 100. That's what we found, order ID, which is 100. Now let's do ordered by unit price, and which is starting at 35. As you can see, I've ordered by unit price starting at 35. It gave me every documents whose unit price was 35, as you can see, 35.95. And the last entry that you could say is unit price is 50. So whatever entries which are greater than 35 will be seen here. Now let's try something order ID limiting to last. So this would basically give you the order ID which is present at the last, and it is not a number because we have performed some post functions, and the strings which are stored now will show you at the last. So those are some filtering functions that I've implemented here. And like, let's say the last one, like limit to first, if I do limit to first 4, then it would give me the first 4 documents. As you can see, the first document here with order ID 1, second document, third document, and fourth document. So yeah, that was the implementation, and we have checked how it looks in the MongoDB. Now, the project was really interesting because I really get to know how can I access the MongoDB using different filtering functions. I really like working with NoSQL database, working with JSON, which is really lightweight, and yeah, also working with Flask APIs to how to get the HTTP request to the MongoDB server using the curl command that we are performing in the Firebase. That was really an interesting experience for me too. So yes, thank you. My name is Shreyash again, and it was really a fun semester, I would say. Thank you so much.